Welcome back. Let's have a look at how to carry on the paper with having a look at the next few questions. So, I've got a triangle here. We've got some lines RS and ST, and they're two sides of a 12-sided regular polygon. So obviously we've got the word regular, which is very important that we understand that. So the word regular means the sides are the same. So automatically, I'm just going to put a line on there to let me know that these two lines are the same. And obviously this changes the situation because now my triangle is an isosceles triangle. They haven't told us that. They expect us to figure this out because they've said the word regular. So it's really important with some of these higher questions that you need to read in between the lines and try and look for what they're trying to ask you to do. So RT is a diagonal of the polygon, and we have to work out the size of the angle STR. So STR is this angle here. So shade it in or highlight it, whatever you want. So first of all, because we've got a 12-sided shape, we want to work out the interior angle, because when we work out the interior angle, that will tell us that. So remember the formula for interior angle is n take away 2 times by 180. That's going to tell you the sum, what all the angles add up to. So I've got a 12-sided shape, take away 2 times 180. That's 10 times 180. That's 1,800 degrees. Now that's what all the angles in a 12-sided shape should add up to. We've got 12 angles, so I'm going to divide that by 12, and I end up with 150 degrees. Okay. So that angle there is 150. I can now work out the rest because I've got an isosceles triangle. So I've got 180 take away 150, which is 30 degrees, but them two angles are the same. So 30 divided by 2 is 15. And there we are. That angle there is 15 degrees. Okay. Question 13 then. So at the beginning of 2009, Mr. Veal bought a company. The value of the company was 50,000. Each year, the value increases by 2%. Calculate the value of the company at the beginning of 2017, and we have to give our answer to the correct nearest pound. So 2009, it's £50,000. Right, 2017, I'm going to use, obviously it's compound interest, so I'm going to do 50,000 times by 1.02 because it's getting bigger by 2%. And that, I got that by doing 100 add 2, which is 102, because the 100 means you're always taking into consideration of the original amount. That as a decimal is 1.02. How many years between 2009 and 2017? It's 8 years. Tap that into my calculator, I get 58582.96905. So that's 58,600 to the nearest 100. Okay, so at the beginning of 2009, the value of a different company was 250,000. In 6 years, the value of this company increased to 325,000. This is equivalent to an increase of X% each year. Find the value of X. Give your answer correct to two significant figures. So we've got 2009, which is £250,000. In 6 years, the value, so 6 years later, so 2009 and 6 years is 2015. The values increased to £325,000. So we need to work out the percentage. So obviously, if I'm doing compound interest, I will do 250,000 times something to the power of 6, because it's 6 years, gives me £325,000. Well, to work out to the power of 6, I'm just going to divide the numbers first. Okay, we've got a calculator, nice and easy. So I get something to the power of 6 is equal to 1.3. Well, that's nice and simple to do, because if I want to work out what number do I times by itself 6 times to end up with 1.3, I just do the 6th root of 1.3 on my calculator, and I end up with 1.04469758. Well, the 1 I'm going to ignore because that means the 100%. So 0.04469, and I want my answer to two significant figures, and it's going to be, well, that's just the decimal. I'm going to have to times that by 100. So 1, 2, 4.469. That's going to be 4.5% then as a percentage, because that's what they want. They want the percentage. That's the decimal. That's the multiplier. I don't want the multiplier. I want the percentage. So I've got to times by 100. Okay, so let's have a look at the next question. So we've now got to shade the region. So let's do this one first. Y is equal to 1. So it's not, sorry, Y is greater to 1. It's not Y is greater or equal to 1. So I'm just going to do with a very dashed line, the line Y equals 1, because it's not equal to. If it was equal to, I would draw a solid line. All the numbers that are greater than 1 are at the above. So the numbers that are not greater than 1, I'm going to have to get rid of, and I'm going to have to shade in, because I don't want that. Okay. I like to shade in the bits that I don't want, so it's out of the way, and I can clearly see some people shade in the bit that they do want. So Y equals 2x. Well, I need to actually draw myself a little diagram for that. I'm going to do that here underneath. Y equals 2x. Well, x and y, and I'm going to do 0, 1, 2, and 3. Well, obviously, to get y, I've got to double my x's. So 0, 2, 4, 6. And I'm just going to get a different color pen because I think it would be beneficial. Okay, so 0, 0, 1, 2, 2, 4, 3, 6. Okay. Again, draw my kind of dash line. Okay, now, how do I know which bit to shade in? Left or right? So Y is, let's have a go back at the top. Not good when that happens. Let's have a look, get rid of that. And what is it? Y is greater than 2x. So Y is greater than 2x. So I'm just going to pick a coordinate here. That's 4, 3. X and Y. So 3 is greater than, substitute that in. 2 times 4 is 8. Is 3 greater than 8? No. So because that doesn't work, that's the bit I don't want. Because if it works, that's the bit that I want. And I'm just going to get rid of that. And there we are. Let's get a different color pen. We've done blue, let's do green. And let's do x plus y is less than 5. Right, I'm going to change that. I'm going to rearrange that to get y is equal to 5 take x. Okay, because if I said x plus y equals 5, I'm just going to rearrange that because it'll make my life a lot easier when I'm plotting my graph. So 0, 1, 2, 3. So to get y, I've got to take 5 take away from x. So 5 take 0 is 5. 5 take 1 is 4. And then 3, and then 2. So 0, 5. 1, 4. 2, 3. And 3, 2. Again. Okay, which bit do I shade in? This bit or that bit? So just going to pick that point there. And my thing was x plus y is less than 5. That coordinate there is minus 1, 2. X and y. So minus 1 add 2 should be less than 5. That's 1 is less than 5. That is correct. So that's the bit I want. So the bit on top is the bit I don't want. And I just put a big fat R in there. And there we are. We have got the bit that we wanted. So a lot of shading in, a lot of scribbling out, a lot of working out, and yes, only for 3 marks. But if you're really good with your straight line graphs and working out and plotting lines, it should be quite simple and straightforward for you. So Tracy is going to choose a main course dessert in a cafe. She can choose from 8 main courses and 7 desserts. Tracy says that to work out the number of different ways of choosing a main course and dessert, you add 8 and 7. Right, is she correct? No. You multiply 8 and 7, don't you? Yeah, because you've got 8 different combinations and 7 different combinations of desserts. So you times them together and that will give you how many combinations you are allowed to have. So let's do this one. We've got 12 teams playing a competition. Each team plays each other team exactly once. And then we have to work out the number of games they have played. Right. So I'm going to say 12 times 11 because the 12th team can't play by itself, can it? So 12 can play by 11 because there's 11 different people they can play with because they can't play with themselves. That's 132 is a number of games. Right, I need to half that because I need to get rid of the doubles. So that's like team 1 and team 2 playing is the same as team 2 and team 1 playing. So I need to half to eliminate those. So if I half them, I get 66. And that's the answer. Yeah. Because, for example, I'm just going to do team 1, team 2, and team 3. Team 1, team 2, and team 3. So that's 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, and 3, 3. Well, first of all, 3, 3 can't play next. 2, 2, and 1, 1 can't play with each other because they're exactly the same. Then I've got 2, 1, and 1, 2. They're the same. 3, 1, and 1, 3 are the same. And then 2, 3, and 3, 2 are the same. So there, you've eliminated half of your selection by a half because you're only left with 3. You had 6 things to start off with, but only 3 of them can actually play because some are the same, and some obviously are saying they're going to be playing against themselves, which can't happen. So that's why you need to half it. So, I've got to solve this now. So x minus 2 squared equals 3. Right, I'm going to do square root both sides. And then I'm going to add 2. Tap that into my calculator. So with the plus and the minus. So when I tap it in with the plus, I end up with 3 point, better not do it over there because it's on the line. So let's change it. So x equals 3.7320500808, or x equals 0.2679491924. And I want it to 3 significant figures, 3.73, or x equals 0.268. And there we are. Answer. Okay. Let's go on to the next question. Number 17 is a histogram. We've got to draw the histogram out. So let's have a look how that works. First of all, to draw your histogram, you need to work out the frequency density, don't you? Right, frequency density is worked out by doing frequency divided by class width. So that's 15 divided by 10, which is 1.5. 30 divided by 5, which is 6. 51 divided by 5, which is 10.2. 36 divided by 5, 7.2. And 18, 75, 15 to 18 divided by 15, 1.2. So I've now got to plot the first one by the frequency density. So my frequency density needs to go up to about more than 10, doesn't it? So I'm just going to do 2, 4, 6, 8, 10, and 12. I'm going to label this side as FD, so I've labeled it. And then the bottom bit needs to go from 140 to 180. So there's no way here that I'm going to start at 0, 10, 20, 30, 40, or start at 100. So what I'm going to say is if that's 140 and that's 0, and I'm going to do a little squiggle to say that I missed things out. 140, 150, 160, 170, and 180. Okay, and I've covered everything. Gone up in tens, but obviously missed some bits out. So the first one is 140 to 150. Let's change the color pen. Let's do blue actually. So 140. Why did it not change? Okay, 140. Still not changing, is it? Still not having it. There we are. 140 to 150. It's going to go up to 1.5. So that's 1, 1.2, 1.4, 1.5 is around about there. Obviously, if you've got a thin ruler and on your thin pencil, it'd be better for you. 150 to 155 is here, and it goes up to number 6. So there we are. Try, and obviously you're going to do this with a ruler, better than mine. The next one is till 160, and it's 10.2. So I know 10's there, and 10.2 is going to be there, and there we are. Okay. Next one is till 165, and it's 7.2. So 7.2 is there. There we are. And the last one is 165 to 118 is 1.2. So 1.2 there. And there we are. We are done. So we've drawn our histogram. The next bit is always the little bit that's tricky, because you always have some pretty difficult questions with histograms. So this one says, work out an estimate for the fraction of students who have a height between 150 and 170. So let's get a different color pen. Let's do red. Nope, not worked. Red. Right, there we are. So from 150 to 170, that's what I want. So what I'm going to do is I'm going to count the number of squares, because I do not know anything about this histogram, do I? Because it just says the table gives information about the heights of 150 students. So I'm going to see what each box represents, basically. So if I have a look between 150 and 155, how many squares do I have? So 5 times 10, 20, 30, that's 150 squares. How many people does that represent? Oh, there you are. It represents 30 people. 30 people. Right. So 1 square would represent how many people? I'm going to divide by 150 on both sides. If I do 30 divided by 150, I get 0.2. Right. So I've got, it tells me, doesn't it? So I've got, over there, it tells me I've got 30 squares there. It tells me already I've got 51 there. The next one is 36. This bit here, I've just got to work out. It's 5 times 6, isn't it? Which is 30. Well, let's add them up. I've got 30, add 51, add 36, add 30. How many squares is that altogether? Okay, I can't use a 30 because that's not 30 people, is it? So I need to do 30 times 0.2 because I've got each box is worth 0.2. That gives me 6. So 30, add 51, add 36, add 6 gives me 123. Does it tell me how many people it was out of? 150 at the top. So a fraction. And there you are. 123 out of 150 is the fraction of number of people of a height between 150 centimeters and 170 centimeters. Okay. Thank you for watching.